This video contains informations extracted from the book of Meriam and Kraige, entitled Engineering Mechanics, Statics. This video is for educational purposes only. Welcome future engineers. We will start our engineering mechanics video series with force vectors. This is a lesson that is a part of the chapter 2 of the book of Meriam and Kraige. We will solve and explain the sample problem 2-1 concerning force vectors operations. We will then apply the laws of sine and cosine and vector components in solving this problem. The problem is, for the vectors v1 and v2 shown in the figure, we are asked to determine the following: a. The magnitude of s, or their vector sum s, equals v1 plus v2. b. The angle alpha between the vector sum s from the positive x-axis. And c. The vector difference d, which is equals to v1 minus v2. In solving this problem, let us follow the 5 steps rule. Let us start by summarizing all the given values. We are given with two force vector which are v1, which is equal to 4 units, and v2, which is 3 units. The direction of v1, or theta1, is 45 degrees from the positive x-axis, while for v2, or theta2, is 30 degrees clockwise from the positive x-axis. The required parameters are: a. The vector sum s of v1 and v2. b. The angle alpha of the vector sum s from the positive x-axis. And c. The vector difference d of v1 and v2. Let us now solve the vector sum s. In solving engineering problems, a force body diagram will help us rationalize the problem. Make sure that all values are correct. We will be using the parallelogram law in analyzing the problem. Let us mirror the length of the force vectors in its opposite side, making a parallelogram shape. Let us remember that the magnitude and direction of the opposite side of each vector is the magnitude and direction of each vector itself. Meaning to say that this is v1, and this is also v2. The resultant vector is the line from the point of intersection of the two vectors crossing the parallelogram, dividing it into half. Let us label this as s. In this problem, we will apply our discussion in the laws of sine and cosine in solving for the vector sum. Let us analyze the angle inside the parallelogram. As given, v1 is making 45 degrees from the positive x-axis, and 30 degrees for v2 as shown. If we make a reference coordinate at this point, we can analyze that v1 is 45 degrees, since 90 degrees minus 45 degrees is still 45 degrees. In the v2, we know that this is also 30 degrees as given. Therefore 90 degrees minus 30 degrees is equal to 60 degrees. Hence, the total angle between the vectors v1 and v2 is 45 plus 60, which is 105 degrees. Let us name this angle as beta, which is 45 plus 60, and that is 105 degrees. Using the law of cosine, we know that the formula is c squared is equals to a squared plus b squared minus 2ab cosine beta. Substituting our variable assignment in our problem, the equation will become s squared equals v1 squared plus v2 squared minus 2, times v sub 1, times v sub 2, times cosine beta. Then, taking the square root of s, and substituting the given, the formula will become, square root of the quantity, 4 square, plus 3 square, minus, 2 times 4, times 3, times cosine 105 degrees. Solving for s using a calculator, we will get a vector sum of 5.59 units. And this is the answer for letter A. In solving for the direction, or the angle of the vector sum s from the positive x-axis, let us first analyze its position in the force body diagram. The positive x-axis in the coordinate is at the right side. Hence, the angle theta sub s, that we are looking, is as shown. Let us apply the laws of sine, in solving for the direction of the vector sum s. The law of sine states that, the side of a triangle divided by the sine of its opposite angle, is equal to any other sides in the triangle, divided by its opposite angle. Let us focus, on the triangle, on the upper side of the parallelogram. In this triangle, v sub 2, can be divided by its opposite angle, which is sine 45 degrees minus theta sub s. Remember that this is the opposite side of v sub 2, and this is the difference between 45 degrees and theta sub s. We can now then use the vector sum s, divided by the sine of the angle in its opposite side, which is 105 degrees. Let us evaluate the equation using the cross multiplication. We can now have v sub 2, multiplied by sine 105 degrees, equals to vector sum s, times sine 45 degrees minus theta sub s. Substituting all the known values, then the equation becomes, 3 times sine 105 equals 5.59 times sine 45 minus theta sub s. Let us now solve for theta sub s. Dividing both sides by 5.59, so that we can simplify the equation on the right side. Transferring the equation from the right to the left, it now becomes, and taking the inverse sign. Let us now eliminate 45, by subtracting 45 on both sides. And multiply both sides by -1. So that we can have a positive value of the theta sub s. Using a calculator, the answer should be 13.78 degrees. That means that vector sum s, is making 13.78 degrees from the positive x-axis. Finally, for required letter C, let us find for the vector difference d. Let us analyze first the problem using the force body diagram. As discussed, a negative vector will have the same magnitude but will have an opposite direction. Therefore, v sub 2 will now become as shown. Let us now label the angles. Make sure that you labeled all given values correctly. Notice that the direction of the negative vector v sub 2 is still 30 degrees, but now clockwise from the negative x-axis. Let us now use the parallelogram law, to analyze the position of the vector difference d. To do this, follow the steps that we have discussed in letter A. This arrow is our vector difference d. In this problem, notice that we can still use the laws of sine and cosine to determine vector d. But this time let us try different approach. and apply our discussion in the vector components. Vectors that are not along, in either the x and y coordinate, or is making an angle from either of the coordinates, will have x and y components. Therefore, the x and y component of v sub 1, and negative v sub 2, are as shown. Notice that we are using the triangle law of combination in showing x and y components of the vectors. We now have the x and y components of v sub 1, and negative v sub 2. Notice that we have add x and y, so that we can determine the distinction of each components. Using our discussion in the trigonometric function, we know that v sub 1y, is v sub 1, sine 45 degrees. V sub 1x is, v sub 1, cosine 45 degrees. V sub 2x is, negative v sub 2, cosine 30 degrees. And lastly, v sub 2y is, negative v sub 2, sine 30 degrees. We are now ready to solve the vector difference. The force vector is the sum of its components. Hence, the equation will now becomes the sum of the x and y components of v sub 1 minus the sum of the x and y components of v sub 2. Remember the assumptions that the y component that is going up is a positive component, and going down is negative. For x components, going to the left is negative, and going to the right is positive. To make sure that we will not be confused of the orientation of the components, let us assign I for all x components, and j for all y components. So, considering all of these assumptions and substituting the values of all the components, our equation will now becomes v sub 1, cosine 45 degrees I, plus v sub 1, sine 45 degrees j, minus the quantity of negative times negative v sub 2, cosine 30 degrees I, plus negative v sub 2, sine 30 degrees j. Substituting the values of the vectors, and evaluating the operations of the equation, we get 4 cosine 45 degrees I, plus 4 sine 45 degrees j, minus the quantity of 3 cosine 30 degrees I, minus 3 sine 30 degrees j. Now, let us combine all force components at x, and force components at y, by identifying the values, with the coefficients, with I and y variables respectively. The force components at x are, 4 cosine 45 degrees, minus 3 cosine 30 degrees. On the other hand, the force components at y are, 4 sine 45 degrees, plus 3 sine 30 degrees. We can now use the Pythagorean theorem, which is the vector difference d, equals to the square root, of the summation of all force vectors at x squared, plus, the summation of all force vectors at y squared. Substituting all the values, and the equation will now becomes the square root of the quantity, 4 cosine 45 degrees, minus 3 cosine 30 degrees, squared, plus, the quantity of 4 sine 45 degrees, plus 3 sine 30 degrees, squared. Finally, using a calculator, we get a vector difference of 4.39 units. And there you have it. Very easy. What AI can't do. He. As a summary, we got a vector sum of 5.59 units. Its direction from the positive x-axis of 13.78 degrees. And lastly, the vector difference of 4.39 units. Thank you for reaching till the end. If you find this video helpful, hit the like and subscribe button. If you want more of videos like this, hit the notification bell, so that you will be notified of my latest uploads. See you next time. Up next.